Okay, I'm going to look at 3D vectors. Now you should have already be quite comfortable with 2D vectors that we've done in year 12. So all we're doing now is looking at 3 dimensions. We've got our x and our y axis there. So if I just mark a point somewhere on, and let's call it point Q, and let's say that that is 2 units in the x direction, and let's just say it's 3 units in the y direction, and let's say it is 1 unit in the z. So this was right 2 there, wasn't I? 2, 3, 3, 1. Then what we could say is that the coordinate of Q is 2, 3, 1. Now in vectors, we've got the I component, the j component, and the k component. This could be displayed differently, it depends on what questions that you do within the book. So we can get a position vector, first of all, just like what we do in 2D. A position vector is all to do with where it comes from the origin of 0. So a position vector is going from the origin to whatever coordinate that you're going for. If I was looking at O to Q, then I would end up saying my position vector is basically 2, 3, 1. This can be written as 2i plus 3j plus 1k. I can also work out the magnitude of this line, that's basically the length of the line, by doing just like what I've done in 2D, where we end up using Pythagoras. We call this O to Q, and we're going for the modulus of it, which means that we square 2 plus 3 squared plus 1 squared, and finally take the square root. So if we do that, then we end up getting root 14. Now in 2D we also looked at direction, and you should be aware of being able to do writing vectors as r theta. If you're not, you might have to look back either in the textbook on chapter 12, or you can look back at your 12 notes. But in 3D, we're not really required to be able to work out the direction that it's kind of going.